Being and Consciousness, Chapter 3 Matter, the Unity and Diversity of the Forms of its Manifestation. 1. The general concept of matter. What is being? Before we tackle matter, let us turn to a more general category, that of being, which is a fundamental worldview methodological problem. In the broadest sense, being is an all-embracing reality, the most general concept of existence, of that which is in general. Being is all that exists. Material things, processes, properties, connections, and relations, even the fruits of the most unbridled fantasy, the fairy tales and the myths, even a sick man's ravings, exist as realities. It follows that being covers both the material and the spiritual. It is, in fact, something really existing. Being is one of the oldest philosophical categories. All the theories of antiquity contained being as a focal category. The totality of natural elements and the logos, the energy principle of all that is, were both seen as concrete manifestations of being. It is a different matter that being could be interpreted in various ways. It could be regarded as something primary and determinate, or as something reflecting a different existential essence inaccessible to direct perception, that is to say, the interpretations varied, in fact, from the directly perceptible by the sense organs to abstract essences or principles organizing the visible being of the world, and cognizable in varying degree, or, on the contrary, inaccessible to knowledge. 1. In medieval philosophy, the terms transcendental and transcendent were current. The former denoted going beyond a finite, empirical existence, and the latter, going beyond the limits of sensuous experience as a form of the knowledge of the world. In Kant's philosophy, these terms acquired an epistemological status and began to refer, respectively, to a priori conditions and forms of knowledge, for example the a priori forms of sensuality like space and time, and also the categories of intellect, like substance, causality, etc., and to that which goes beyond the limits of possible experience, which is actually inaccessible to theoretical knowledge but is the object of faith: God, the soul, immortality, the antithesis of being or something is nothing. All the concrete forms of being, such as stars or plants or animals, emerge as it were out of non-being and become actual, present being. But the being of that which is, however long it endures, comes to an end and returns to non-being, losing the given form of existence. The dialectical aspect here is that the transition to non-being is destruction of a given form of being and its transformation into a different form. The emergence of a given form of being is a result of the transition from one form of being into another. Non-being is a relative concept. There is no non-being in an absolute sense. These categories were closely studied by Hegel, who filled them with profound dialectical content connected with the idea of development, of becoming. Hegel began the construction of his philosophical system with the most meager and abstract concept of pure being, nothing. Why this concept, precisely, is being devoid of any definiteness. After all, it covers all that is in the infinite variety of its concrete manifestations. Doesn't it encompass both the material and the spiritual world with their properties, relations and interactions? Yes and no, if when we view the whole world we can only say that everything is and nothing more, we are neglecting all speciality and, instead of absolute plenitude, we have absolute emptiness. Therefore pure being is, according to Hegel, so meager and empty that it is indistinguishable from nothing. Of course, Hegel realized all the paradoxically of the situation, and he said that common sense could laugh all it wanted here. How's that? Being identical to nothing, doesn't man really care if he has any money in his pocket or not? Such is the irony of common sense. But this irony is the fruit of intellectual ineptitude. Pure being is connected with the beginning, and the beginning, with the existence of a possibility. The possibility itself is something. It is not a formed something but something as a potential, a form, folded for the time being, of future being. An embryo or potential combines being and non-being. It is a two-faced identity of nothing and something. a unity of opposites subject to anxiety and tension. Within it, hidden work goes on, leading to a becoming, to the transition of nothing into something. In a word, there is no absolute nothing, for it is the starting point for the manifestation of something. Whatever forms of being we might consider, they all of them have matter as their deep-lying foundation or substance. Spiritual 1. The Logic of Hegel, page 163. Reality, 2, exists in unity with matter and is defined in terms of it. Matter and spirit are the most general philosophical concepts. On the history of the development of the category of matter. Matter is a basic category of philosophy. Its interpretation determines the approach to practically all the other philosophical problems. Etymologically, the term goes back to el materia, substance. This substantial meaning of the term survived until the 20th century. Then a revolution took place in physics which signified the crisis of the one-sided interpretation of matter based on obligatory sense perception, which was the essence of the concept of metaphysical materialism. The unity and diversity of all the forms of manifestation of matter can only be understood on a historical approach, through generalization of the experiences of scientific and philosophical knowledge. We have already pointed out that the first stage in the realization of the materiality of the world was spontaneous materialism. The starting point of the formation of the concept of matter was the transition from the qualitative diversity of existing things to the concept of primary matter, the single basis of the world embracing all this qualitative diversity. The difficulty of the intellectual operation of abstraction necessary for that is clear from the fact that at first all the qualitative diversity of the world was deduced from a single qualitatively definite and empirically perceivable element, say water or fire. But Democritus noted already that it was impossible to explain the origin of a qualitatively definite substance in terms of another such substance. No element contained in it the principle of its transfiguration, and it had to be explained just why it had a given quality. Further movement of thought inevitably led to the unification of all the first principles of being, ultimately resulting in the idea of the world's atomic structure, of which the underlying basis was the particles, or atoms, inaccessible to the senses. But atoms were also interpreted as substance, as the smallest building bricks out of which all that is built. The qualitative diversity of this building material depending on the various types of interaction among them. This marked the birth of the discrete picture of the world, which persisted until certain discoveries were made in physics at the end of the 19th century, and which presented being as consisting of tiny isolated, discrete particles interacting among themselves in a particular fashion. This view, which took shape already in antiquity, proved to be of great heuristic value and therefore very stable. It was the starting point of scientific explanation of many natural phenomena. Relying on the idea of atomism, Newton introduced the concept of mass in physics, and formulated the law of universal gravitation, and the principal laws of motion. Atomistic views underlie the molecular kinetic theory of heat, and in chemistry they played a role in the discovery of the law of conservation of matter. Mendeleev's periodic system of the elements was also created on the basis of atomism. Newton's mechanics, which afforded an explanation of most phenomena and events in the world on the basis of interaction among atoms, asserted the mechanistic, atomistic picture of the world and served as a model of scientific precision for other sciences. Matter in the form of atoms, and motion in vacuum, were the two main principles of Newtonian mechanics. The mechanistic materialist principles seem to be able to explain the essence of all the phenomena occurring in the world. The finest psychical facts included, and theoretical physics, which studied the fundamental properties of atoms, looked like it might complete its search any time now, assuming a fully finished form. However, along with the triumph of atomism, a crisis was gradually coming to a head, connected above all with the discovery of new facts, which could no longer be adequately explained in terms of the atomic structure of matter. Besides, the atom itself proved to be a far from simple, and not at all the smallest particle of matter. The electron was discovered, as well as radioactive decay and transmutability of atoms. The atom, which was previously seen as faceless and structureless, proved to possess an extremely complex inner structure consisting of a nucleus and electrons revolving round it. Still more critically dangerous to mechanistic materialism were the new views in the theory of interactions, where the heretofore unknown interactions within atoms and nuclei had been discovered. This crisis was connected with the introduction into physics, by Michael Faraday and James Maxwell, of the new basic concept of field, which describes a state of matter fundamentally different from substance. Now, what is the special physical and philosophical meaning of the field concept? And in what way has human thought arrived at this new form of matter? Originally, field was defined as space surrounding some material object, for each point of which it was possible to determine, in terms of mathematical equations, the magnitude and direction of the force of interaction between the given and some other object. Thus the tension of gravitation, the principal type of interaction between objects, calculated by Newton, varies at different points of the field, that is at different points of the space surrounding an object. However unexpected these mathematically definable data, in which the medium of interaction actively participates in the process, might be, they merely undermined somewhat but did not entirely destroy the notion of matter as substance, for a field of this kind could still be thought of as an attribute of substance. The field became a really disturbing factor only when it was conclusively proved that it was not just an attribute of an object, but an independent physical reality, capable of existing and spreading in space, regardless of the material object. The field thus became, along with substance, a new and particular form of matter of which continuity rather than discreteness was the main trait. However, before the field concept became generally accepted, it had caused a storm of indignation among physicists and philosophers, and then, as the latter became accustomed to it, it led to a philosophical crisis, for it shattered the concepts of matter and substance. Matter has disappeared, the scholarly world exclaimed in consternation when physicists, handling the new concept with the delight of neophytes, began to explain the properties of substance by the action of fields. Matter indeed disappeared, giving way to the new god, the field. Newton's classical mechanics stated that such fundamental properties of matter as mass and volume are absolutely immutable, basic, and not conditioned by anything. Experiments showed, though, that electron mass depends on the field the electron creates and varies with field energy. Consequently, particle mass varies with changes in field structure. Mass also changes with body velocity. As electron velocity approaches the speed of light, the tension of its field tends to infinity, and its mass changes accordingly. Since mass was regarded as the measure of the quantity of matter, the discovery of mass inconstancy, its variability depending on the changes in the field and in body velocity, was interpreted in the sense that matter had disappeared and materialism collapsed. The radioactive decay of atoms was interpreted in the same sense. It was perceived as transformation of matter into energy, as disappearance of matter. In itself, it did not yet signify the replacement of materialism by idealism, but it was accompanied by distinctly idealist tendencies in epistemology. Unable to sensually perceive, and conceive of, micro-objects, physicists had to resort more and more to mathematical models, relegating matter, the earthly roots, so to say, of these models, to oblivion. Some physicists, as for example Ernst Mach, tended to think that these constructs were no more than the fruit of pure thought. Matter evaporated in the haze of mathematical constructs, and the constructs themselves turned out to be self-sufficient essences. The whole reality was thus reduced to abstract ideal structures. Public opinion turned to idealism, for materialism was traditionally linked with mechanistically substantial notion of matter. This situation urgently required some resolution. Objectively, the whole ensemble of new discoveries was dialectical in character. To overcome the crisis in physics, theoretical thought had to take a more flexible approach to facts, in particular to the connection between matter, motion, space and time. A much subtler approach was needed to the notion of truth and its mutability. It had to be understood that truth is process. In the picture of the world that was becoming clearer and clearer in science, it was precisely change, transition, transformation, and development that needed dialectical explanation. But scientific thought was still enthralled by the mechanistic tradition. New discoveries in science called for profound changes in the very mode of human thought. Thus the agonizing process of the breakdown of old, familiar concepts began. The dialectical materialist conception of matter. The critical situation in natural science and philosophy was resolved in dialectical materialism, which replaced mechanistic materialism. To overcome the crisis in the understanding of matter, this category had to be clarified, first of all, in the light of new natural scientific data, which was only possible if it were consciously subjected to dialectical analysis. The category of matter had to be freed from the allegedly inalienable links with the concept of substance, and then given a definition that would reflect its really universal content. It would therefore be absurd to add any new attributes to the substantial conception of matter, to add, say, electromagnetic, gravitational or some other, as yet unknown, fields to matter as objective reality existing in various forms of substance. On this path, every new fundamental discovery of new forms of reality would each time bring about a critical worldview situation. Again and again voices would be heard about the breakdown of materialism. Again and again it would be necessary to add a new variety of matter to its definition, and that would inevitably mean falling into bad infinity, rejecting the unacceptable, from the dialectical standpoint, tying up of matter with the physical modes of its existence. Lenin said that it was sheer nonsense to say that matter was connected with substance only, and that dialectical materialism had at any time professed a mechanical rather than electromagnetic or some other, immeasurably more complex, picture of the world of moving matter. Lenin saw the way out of the crisis in the natural scientists' acceptance of dialectical materialism. Physics went astray into the clutches of idealism precisely because physicists did not know dialectics. It was not matter that had disappeared but the metaphysical conception of it, and the new discoveries could only be correctly understood from the positions of dialectical materialism, which never reduced matter to any immutable and further indivisible building bricks of the universe. The path towards a dialectical definition of the concept of matter as the single substance of the world does not lie through listing its properties, but, as Lenin showed, continuing the materialist tradition of the French philosophers of the 18th century, in particular Holbach, through correlating it with consciousness. Matter is a philosophical category denoting the objective reality which is given to man by his sensations, and which is copied, photographed and reflected by our sensations, while existing independently of them. Although Lenin relied on the entire materialist tradition, he introduced a fundamentally new element in the interpretation of the essence of matter, stressing that the sole property of matter with whose recognition dialectical materialism was bound up was the property of being an objective reality, of existing outside the mind. Idealistically minded physicists and philosophers tried to refute Lenin's definition of matter on the grounds that science already knows manifestations of matter that are not given in sensations. Hence a definition of matter as existing outside consciousness and reflected in sensations is unjustifiable. But they did not take into account the fact that matter is given us in sensations not only immediately but also indirectly. Most manifestations of matter that we know of are not immediately perceived. There are phenomena that are in principle inaccessible to our sense organs, like the elementary particles of which scientists can only judge by observing the traces of their interaction with extremely sensitive instruments. In this case, an instrument is a modified organ of human perception of matter, and before drawing some fresh conclusion concerning the structure of matter, man necessarily comes in contact with it. Thus the objective existence of electrons was also proved experimentally. The world that is not given us in immediate sensations is explored by human 1 v.i. Lenin. Materialism and Empirio-criticism. Critical Comments on a Reactionary Philosophy. Collected Works, Volume 14, Progress Publishers, Moscow, 1977, page 130. Thought through specially devised experiments. The difficulty here is in learning to adequately interpret the data obtained in the course of an experiment. Idealistically minded philosophers also asserted that Lenin's definition of matter concealed idealism. If matter can be defined through its relation to consciousness, the former depends on the latter, and not vice versa. Here, too, their arguments proved untenable. Matter is the substance of that which is. It has self-being in its spatio-temporal infiniteness. It is self-sufficient and does not need anyone to be aware of it. In the rays of human reason, however, it is reflected in sensuous and conceptual images. The antithesis of matter and consciousness, just as their relationship on the whole, is by no means absolute but relative, a fact that Lenin pointed out unambiguously, the antithesis of matter and mind has absolute significance, only within the bounds of a very limited field, in this case exclusively within the bounds of the fundamental epistemological problem of what is to be regarded as primary and what as secondary. Beyond these bounds the relative character of this antithesis is indubitable. 1. Thus the concept of matter as objective reality is identical with that of the single substance with all its properties, laws of structure and functioning, movement and development. Lenin's definition of matter is therefore leveled both against objective idealism, which posits the spirit as the substance of being, and against subjective idealism, which assumes that all objects are mere complexes of our sensations. As we have already noted, apart from clarifying the concept of matter, natural science had to be moved on to dialectical ground. What did this actually mean in connection with the new conception of matter? Wherein did dialectics lie here? A scientist must not be confused by real or apparent contradictions in the structure of matter. Neither the substance-based discreteness of the world, nor its field-based continuity, are the final attributes of the structure of matter. These attributes are only antithetic at the formal level of thought, while in reality they dialectically complement one another, being different forms of the manifestation of the same essence. This dialectics of reality must be reflected in the minds of scientists. For them, the apparent antithesis between different forms of the manifestation of matter must serve as a stimulus for further inquiry into one ibid. Page 147, the as yet unknown phenomena rather than as a pretext for hastily announcing a crisis. It was precisely through application of dialectical methods that physics found a way out of the crisis. The principle of the material unity of the world, a dialectical theory of matter, cannot be exhausted by its philosophical definition only. It was also necessary to construct an integral and comprehensive conception of matter. This called for the application of the entire historically accumulated arsenal of dialectics, and in the first place for a substantiation of the dialectics of the discrete and the continual in matter, as well as an explication of the unity of matter and mind, reflected in the dialectical principle of the material unity of the world. Two basic philosophical positions can be tentatively identified in the treatment of the issue of the unity of the world. On one of these approaches, the universal unity of all world phenomena is believed to lie in their materiality, the line of Democritus, and on the other, in the common ideal basis of the world, the line of Plato. Both of these positions are monistic, for the basis of the world is seen in one substance only. The former position is called materialist monism, with dialectical monism as its highest stage of development, the latter, idealist monism. Apart from these two varieties of monism, there also exists dualism and pluralism, that is, recognition of several equal first principles of the world irreducible to one another embodied, for example, In the ancient conception of the four first elements, water, earth, air and fire, it is clear from the above that two principal issues are at stake here: the primacy of matter or of spirit, and the possibility or impossibility of reducing the entire qualitative diversity of the material world to the single universal substance. Now, how are these issues approached from the dialectical monistic positions? The fundamental premise of dialectical monism, the real unity of the world consists in its materiality, means that consciousness, the spirit, the ideal are both a knowledge of the material reality and a component part of this reality, and that there is no unbridgeable gap between the material world given us in sensations and man's consciousness. Consciousness is not something uniquely supernatural but a natural property of highly organized matter. Dialectical monism rejects the separation of consciousness and reason, as a special substance opposed to nature and society. The reality surrounding us, and we ourselves, form a single material world. Unity is not conceived here as qualitative similarity, but as a unitary substantial basis that may assume the most diverse forms, among which natural material and ideal forms are the most antithetic ones. However, the statement of the material unity of the world does not by itself solve all the questions arising here. The idea of unity is inevitably linked with the concept of universal interaction. If the unity of the world was thought of only in terms of its materiality, without the concept of interaction, the existence of different and entirely unconnected material worlds could easily be accepted as a logical inference, but that would have meant pluralism of the worlds rather than the unity of the world. For the same reasons, it is logical to accept the dualism of mind and matter, for in this case, too, interaction between them is ignored. Matter is thought of as existing by itself, and so is spirit. The process of world development could not be explained, either, unless we recognize the fundamental importance of the continual and universal interaction of all things with all other things in the world. Development was inexplicable within materialist monism in its mechanistic form, while dialectical materialist monism, with its principles of universal interconnection and interaction, has precisely the idea of development as its core. The interpretation of the unity of the world from the positions of dialectical monism entailed yet another extremely important consequence. It permitted the view of human society as one of the forms of the development of matter. While previously society, in view of its special subject-object nature, could not be squeezed, as it were, into the traditional notions of matter, the insistence of dialectical monism on the primacy of matter entails the existence of a single substance as the basis of the qualitative diversity of the world of nature and the world of man. Here we run into a difficulty that only dialectics can resolve. This difficulty is bound up with the concept of substance in the special philosophical sense, L substantia essence. We have spoken several times already of the existence of such a single substance, but is there any difference between the concepts of matter and substance? Why is it necessary to introduce this latter concept of which the content appears to be a replica of the basic concept of matter? Historically, the category of substance was indeed thought of as an almost complete synonym for matter in its present acceptation, but the development of dialectical materialism, and continuous clarification and specification of the logical status of all its categories, above all the category of matter itself, made it clear that a special category was needed to designate the single natural basis of the world, not in terms of the epistemological antithesis of spirit and matter, but in properly existential and ontological terms. On the epistemological plane, matter and mind are antithetical, whereas on the ontological plane they must be identified, as it were, if we are to adhere to the principle of materialist monism. So the concept of substance, in which the relative antithesis between matter and spirit loses its significance, was introduced precisely to designate the common basis of the entire indivisible material being combining both spirit and matter, the discrete and the continual. The concept of substance is the result of the ontological deepening of the concept of matter. 1. It must be clearly realized, though, that the concept of substance is inseparably bound up with that of matter. These are two aspects of one essence. Substance is not some third entity embracing both mind and matter, as Ernst Mach believed, for instance, but matter considered outside its relations with consciousness, matter in which consciousness is already regarded, firmly and without reservations, as its attribute. If substance is understood outside its essential links with matter, its union with the sphere of the ideal is inevitable, and then matter will be regarded as an attribute of the spirit. As in objective idealism, substance again leads us to natural scientific problems, for it is here that the battles were fought over the unity of or difference between the first principles of material being, and over the question whether there was one or many substances underlying it. That was the meaning of the controversy in physics at the turn of this century, concerning the wave, continual, or corpuscular, discrete material, substance of the world, modern science on the material unity and diversity of the world, the dialectical materialist conception of the material unity of the world, and of the inexhaustibility of the structure and properties of matter, was confirmed by the achievements of 20th century science, of physics in the first place. The antithesis between continuity and discreteness, which caused such a stir among the physicists early in this century, was dialectically expressed in quantum mechanics with its discovery of such a property of matter, as its corpuscular, and at the same time wave structure. This synthetic property is found, for example, in photons, or particles of light. Their corpuscular wave nature was one in some contexts in this volume. For example, see above or further below. The term substance is used in the less philosophical sense of physical matter or materiel. Tr established owing to the discoveries of Einstein, Bohr and Schrödinger. The dialectical method of thought in physics manifested itself strikingly in the fundamental principle of complementarity, according to which neither a corpuscular nor wave theory description of the material properties of the microcosm taken separately can provide an exhaustive understanding of the facts known to science, and only their dialectical combination can ensure the adequacy of scientific propositions. Underlying the formal antithesis, the scientists saw a reflection of essential properties of the single material substance, which was not, however, exhausted even by these corpuscular wave notions. Substance is the same in all its formerly antithetic properties. That is now an indubitable fact confirmed both theoretically and experimentally. Now, what is the picture of the world, and of its inner unity from the standpoint of present-day science? On the one hand, matter has a granular, discontinuous structure. Consider the elementary particles, atoms, molecules, stars and their systems, galaxies, etc. On the other hand, matter is marked by continuity, found in various kinds of fields, gravitational, electromagnetic, nuclear, etc. Substances and fields are the two principal forms of the existence of matter known to science. A substance is defined as something that has mechanical mass, rest mass. We can speak here of hierarchically arranged structures, as it were, from the atom to celestial bodies of any conceivable size. The atoms themselves have a complex structure. They consist of elementary particles, the protons and neutrons that form the nucleus, and of electrons revolving round the nucleus at fantastic speeds. At present, science already knows a great many other elementary particles, mesons, hyperons, neutrinos, etc. They exist both as parts of atoms and in the free plasma state, as for example in the residual cosmic radiations reaching us from the universe's past. Science has also discovered antiparticles, the antipositron and others, having the opposite sign of the electric charge. Elementary particles, just as photons, have corpuscular wave properties. They are both discrete and continuous, being particles and waves simultaneously, and they have both mass and a definite electric charge. In the form of various substances, matter exists in diverse states. The most widespread state of matter in the universe is plasma, which consists of electrically charged particles, electrons and ions that have not yet formed atomic and molecular bonds. The stars, the nebulae, interstellar gas are all plasma. The solid, liquid, and gaseous states of matter are extremely rare in the part of the universe known to science. The continuous forms of matter include fields, that is matter without rest mass. Fields connect the particles of matter, enabling them to interact and therefore to exist. Without gravitational fields nothing would bind atoms within molecules, electrons and nuclei within atoms, stars within galaxies, and substance itself in stars. In general, all bodies would have ceased to exist. But the boundary between substance and field must not be regarded as absolute in the sense that only the same unchangeable fields and the same constant and immutable particles of substance exist in the world. This conception would lead to dualism. The deep unity of all matter in the universe means that the concepts of substance and field are relative with respect to each other. Their relativity is not only a dialectical imperative that follows from the principle of substantial unity of the world, it is also an experimentally verified and scientifically demonstrable fact. Science has established that the boundaries between field and substance are relatively constant, only in the macroscopic world, accessible to sense perception. In the realm of microphenomena, these boundaries are obliterated, as it were, so that substance and field become mutually convertible. Thus mesons are particles of substance and at the same time quanta of a definite field. All the contradictions in the views of the structure of matter, arising in science, are the result of the relativity of our knowledge about objective reality. Scientific thought keeps completing, and then drawing all over again the picture of the world which appears to us as an infinite variety of the forms of being of matter, and the properties, connections and laws prevailing in it, and resting on the solid foundation of the substantial unity of the world. Science moves from one level of the perception of the unity of the world, through the study of the diversity, to a new level of understanding its unity. The principle of conservation of matter. One of the attributes of matter is the fact that it cannot be either created or destroyed. This is displayed in a set of natural scientific laws of conservation of matter in all its mutations. The process of change of the forms and states of the material substance is practically unlimited. Thus physics has discovered the universal transformability of elementary particles and of forms of motion of matter. For instance, friction caused by mechanical motion leads to accumulation of the body's inner energy, to acceleration of the heat motion of its molecules. In its turn, this motion can be transformed into electromagnetic or chemical one. In the microcosm, the particles of matter are transformed into radiation, and vice versa. Field processes can result in the emergence of matter. However, in all these transformations matter is preserved as substance, or the basis of all change. The principle of conservation of matter, just as that of the material unity of the world, entails, when logically unfolded, two other fundamental principles of dialectics: universal connection and development. Any object emerges, develops, functions and disappears only in connection with other objects. The birth of a thing does not mean birth out of an absolute nothing, but its emergence out of another thing. Just as destruction only signifies its transformation into another thing. In all these transformations, births and destructions, material substance remains immutable. It neither comes into being nor does it disappear. Matter changes only in connection with its conservation, and conservation is manifested only in the changes of its forms. The principle of the uncreatability and indestructibility of matter is of great worldview and methodological significance. It permits a deeper and fuller understanding of the processes occurring in various spheres of reality, and it remains the guiding principle in the formation of the most up-to-date hypotheses of the origin of the universe. The controversy concerning the principle of conservation, uncreatability and indestructibility of matter flared up with renewed force after the idea of a stationary universe, which had prevailed in science, was replaced by the idea of a changing universe regarded as a dynamic process of change, of constant transition of one form of matter into another, rather than as a static system, inasmuch as the idea of development is in excellent harmony with the principles of the material unity of the world, and of conservation of matter. The idea of continual change in the universe could not in itself raise any objections. It was not the idea of development that caused the controversy, but the starting point of that development, the origin of the universe, and its final point, the death of the universe. First, there was the controversy concerning the theories of the death of the universe, say, through dissipation of matter in infinite space, and this was followed by a controversy on the theories of the origin of the universe, as a result of the so-called Big Bang. In the first case, some scientists saw a theoretical possibility of the destruction of matter, while in the second the question arose of creation, or emergence of matter practically out of nothing. Let us consider these two scenarios in greater detail. First, the theory of the emergence of matter in the universe. The universe, says the English astronomer James Jeans, lives its own life and follows the road from creation to extinction just as we mortals. Science knows no other change but movement towards old age, and no other process but progress towards the grave. We see that stars are continually melting away into radiation, just as eternally and incessantly as an iceberg melts in a warm sea. The sun at any given moment weighs a few thousand million tons less than it did a month before. Since other stars are melting down in the same way, the universe is on the whole less material now than before. Not only does the quantity of matter diminish in the universe, what remains is continually dissipated in the icy cold of space at a colossal and menacingly increasing speed. The material universe seems to be going like a tale already told, dissolved in non-being like a ghost. The untenability of this hypothesis is due not so much to its failure to take into account the principle of mutual transformability of different forms of matter and energy, as to its assumption that space is absolutely independent of matter, and that the matter of the universe will be dissipated in this space, in the form of the tiniest particles. According to present-day notions, space is not accidental in relation to material substance but a reflection of its essential structure. The three-dimensional space that we know from everyday experience expresses this essence only in the visible world, while at the micro and macrocosmic levels it has a greater number of dimensions. The folding up of several dimensions of space may result in the appearance of what we perceive as matter. This close bond between space and matter, their essential identity discovered by modern science, signifies the untenability of the theory of dissipation of the matter of the universe to the point of complete disappearance, a theory in which space is conceived as an exterior attribute in relation to matter. Similar problems arise in connection with the hypothesis of the origin of the universe in the Big Bang. According to that hypothesis, some 15,000 million years ago there was an explosion of superdense material substance, and what we observe now is the result of that explosion, an expanding universe. The state of matter which exploded in that Big Bang, and the causes of that explosion, have not yet been exactly established by science, and this inevitably gives rise to hypotheses challenging the principle of the uncreatability of matter, some of them even reviving the original Christian dogma of the creation of matter out of nothing. The fact itself that we know nothing of the state of matter before the explosion, or of the causes of it, in no way contradicts the principles of the material unity of the world and uncreatability of matter. The development of science has already resulted, on more than one occasion, in revolutionary changes in the views on the concrete structure of matter, and it will also lead to such changes in the future, without in the least affecting the philosophical category of matter. However, in connection with the Big Bang theory, some scientists have expressed views that are very close in import to the physical idealism of the late 19th century, as various processes in the expanding post-Bang universe were clarified. The view has been expressed that matter emerged out of the so-called physical vacuum, in which a complex process occurred of spatio-temporal fluctuation, which led to the emergence of substances and of various fields. It follows, however, from the scientific meaning of the term physical vacuum, that it is not a nothing but a concrete physical object, which has material nature so far unknown to science. Just as in the case of the field concept, scientists will quite possibly arrive someday at the conclusion that there is yet another form of matter, next to substances and fields, hidden here. Matter is infinite in its manifestations, and its one constant property is independence of human consciousness. The illusion of the origin of matter out of nothing, connected with the idea of physical vacuum, is largely due to the not quite felicitous term itself. Just as mechanistically reasoning minds in the past saw the field concept as a threat to matter, understood entirely in terms of substances, so now many make the same error, having grown accustomed, as Einstein said, to the field concept as to the chair they sit on, having forgotten that it once provoked just as turbulent discussions as the physical vacuum concept now. Present-day idealist physicists are ready to infer from the concept of physical vacuum, which they themselves developed, a disappearance of matter, or rather its emergence out of nothing. In actual fact, though, physical vacuum is a real physical object of material nature, and not just a result of mathematical calculations. There is thus no time or place where matter would lose its capacity for new transformations. All conceivable transformations of matter are possible except two: emergence of matter out of nothing and its passing into nothing. There is no place from which matter could appear, and no place into which it could disappear. It is the source, the cause, and the effect of itself. It exists in and for itself. It is indivisible in its self-being, and owes its existence to nothing and no one. The principle of conservation of matter was also confirmed by the following proposition evolved by present-day science: the total energy of the universe, the latter regarded by most scientists as closed, equals zero, that is to say, the quantities of negative and positive charges are mutually balanced. It follows from this proposition that the indestructibility and uncreatability of matter, or, in other words, matter existing always in one and the same quantity, is a necessary condition of the existence of the world. Energy being the measure of matter's motion. 2. Motion as the mode of existence of matter. The concept of motion, the unity of matter and motion. Everything in the world is in continual motion, changing its form, being transformed, and wavering between being and non-being of all individual existences. Myriads of stars that we admire on a clear night merely appear to be motionless. In actual fact, they move at enormous speeds. Every star is a sun with its own ring of planets, along with the satellites revolving round them. The stars rotate round their axes and participate in the rotation of the galaxy round its axis. In its turn, our galaxy moves in relation to other galaxies. Besides, according to the latest cosmogonic hypotheses, the universe is not a mechanism with parts constantly moving along strictly determined orbits. It is an expanding universe continually moving towards ever new states. All that lives is in incessant movement. Everything feeds, grows, multiplies, flourishes and dies. Innumerable inner processes occur in every living system: pulsation of energy and information, processing, assimilation of foodstuffs and ejection of waste. Everything is in an eternal state of becoming something else, and that not by coercion but of its own free nature. Since motion is an essential attribute of matter, it is, like matter, uncreatable and indestructible, absolute, unavoidable, and universal. Matter and motion are of the same essence. Motion is the mode of existence of matter. To be means to be in motion. The question of the first cause of matter, and the primary source of motion, is essentially one and the same question. We know from the history of science and philosophy that the original source of universal changes, of the motion and development of all that is, just as the source of the existence of matter, was often thought of in a reference frame comprising the omnipotence of divine power and universal will. Materialism, on the other hand, especially dialectical materialism, relies on the data of science which prove that motion, just as matter, is uncreatable and indestructible, that it is not introduced from the outside but contained in the very nature of matter. Some forms of motion are transformed into other forms of motion, and not a single kind of motion emerges out of nowhere. Motion is self-motion in the sense that the tendency, the impulse towards a change of state is inherent in matter itself, it is its own cause. If the universe came into being after the Big Bang, the causes of that Big Bang must be sought for in matter itself, not in some external force. The dialectics of motion and rest. Motion is not a pure continuum but the unity of continuum and discreteness, of change and stability, of disturbance and rest. In the endless flux of ceaseless motion there are always moments of discrete stability, manifested above all in the conservation of the inner nature of each given motion, in the form of equilibrium of phenomena, and their relatively stable form, that is relative rest. Thus the physics of elementary particles proves that these particles can only exist as transmutations of elements of a system, that they exist and are conceived of only in motion. But at the same time physics also points to the objective reality and immutability, that is rest, as a characteristic of the process itself of the transmutations of particles. As distinct from field, substance has a property expressed in the physical concept of rest mass, but there is also an element of stability in field motion itself. The stability of the rate of change is also a form of manifestation of immutability. In this case, rest is conservation of a definite, in this case quantitative, state of motion. Each kind of field has its immutable, stable characteristics. Thus rest only exists as a characteristic of motion in some stable form. Whatever the object's changes, as long as it exists, it retains its definiteness. Absolute rest is impossible, for to attain absolute rest would mean to cease to exist. Rest is always relative in character. Bodies can only be at rest in relation to some reference system tentatively accepted as motionless. A body's motion, Einstein said, is always understood as its position in relation to another body. Thus the relationship between continuity and discreteness is handled in philosophy, in terms of the dialectics of motion and rest. The philosophical controversies around the principle of unity of matter and motion. The history of science and philosophy knows quite a few systems in which matter and motion were perceived as two independent and isolated substances, rather than as essentially forming a unity. This issue is of fundamental worldview meaning, for matter in this case was regarded as a kind of passive, inert element devoid of any interactiveness. To set this dead matter in motion, a divine first push was certainly needed. In the sciences that sought for mechanical principles of the emergence and existence of all phenomena, this approach assumed the form of notions of hidden forces, the first impulse, God, alien vital, spirit, etc. In our times, more influential proved those theories, isolating matter from motion, which did not spring from the idealist positions of their authors, but from the development of natural science itself. This refers in particular to the energism, which is already overcome, however, by present-day science. In energism, the possibility of regarding motion as an element of the world isolated from matter was founded on the fact that the natural, scientific concept of energy as a measure of motion permitted a unified description of many physical processes, which were previously regarded as entirely different and irreducible to one another. Energy began to be thought of as the common denominator of all the natural processes, so that some physicists decided that there was no need to consider the concrete mechanisms of these processes, since all of them could be covered by the energy concept. From this standpoint, energy is the only objective substance, while matter is merely a secondary and accidental consequence of it. For instance, Henri Bergson believed that mutability, or motion, did not at all imply the existence of a changing object, it was itself the thing. Motion was clearly raised to an absolute here. The same view was held by Wilhelm Ostwald, who insisted that only energy existed in the world. What would a person feel when hit with a stick? The stick or energy? Certainly energy. Everywhere where people are accustomed to feel and see matter, they feel and see only pure energy. According to Ostwald, the processes involving energies are manifested, through our consciousness, as physical phenomena. The discovery of the law of conservation and transformation of energy, and the successes of thermodynamics stimulated again these persistent attempts to lift pure energy to an absolute, the ultimate content of all that exists. But pure energy is no more than an abstraction. Energy is one of the characteristics of the intensity of interaction between material objects. It is motion which is just as impossible without a material vehicle as thought without a thinking brain or blueness without something that is blue. In scientific research, one often has to single out only the energy aspects of certain processes, ignoring their vehicles. This abstraction is quite justifiable. As long as the real structure of elementary particles is unknown, researchers generally restrict themselves to descriptions of transmutations of particles in terms of energy only. But if this procedure is treated as an absolute one, energy is sometimes interpreted as an indestructible, stable substance out of which elementary particles are, as it were, constructed. Sometimes it is the photons that are identified with pure energy. The discovery of light pressure has shown that photons are not only waves, but also tiny accumulations of matter, possessing both energy and mass. Since the time of that discovery, energism has virtually ceased to exist, but there were traces of it in some interpretations of the law binding the mass and energy of material objects, E equals mc2. Where energy E equals mass m multiplied by the second power of the velocity of light c, erroneously identifying mass with matter. Physicists believed that matter could fully pass into a concentration of pure energy, but mass is a measure of such properties of matter as energy and gravitation, and energy is a measure of motion. There is neither pure energy without mass nor mass without energy in nature. For instance, the proponents of the idea of total transformation of mass into energy often cite the example of the transformation of the electron and the positron into the electromagnetic field, ignoring the fact that the electron and the positron are not pure energy-less mass, nor is the electromagnetic field pure energy. The field has its mass expressed in the concept of field quanta. Any object of reality possesses mass and energy, rest and motion, linked by a definite interdependence. The diversity of the forms of motion and their relationship, reductionism, its necessity and danger, in classifying the forms of the motion of matter, dialectical materialism, relies on the achievements of the natural sciences, and on the philosophical view of motion, as the mode of the existence of matter, and singles out a number of basic forms out of their immense diversity. The first scientific classification of the forms of motion was proposed by Engels. The forms which he identified were mechanical, physical, chemical, biological, and social. This classification still retains its significance, although it has been significantly enriched, of course, by the achievements of contemporary science. The forms of the motion of matter are organically linked with a definite level of its structural organization, each of which being characterized by a system of laws and a vehicle of its own. The starting point in this hierarchy is the submicroelementary level, the hypothetical form of the existence of matter having field nature, out of which elementary particles are born, the microelementary level. At the next stage nuclei are formed, the nuclear level, which are the building material for molecules, the molecular level. Molecules combine into aggregates, gaseous, liquid, and solid bodies. The macroscopic level. The latter form stars, planets, stellar systems, metagalaxies, etc. The cosmic level. The organic level is the result of gradually increasing complexity of the molecules of carbon compounds, which has led to the formation of organic compounds. Life was the necessary, law-governed outcome of the development of an ensemble of chemical and geological processes on the Earth's crust. The evolution of life proceeded from precellular forms of protein existence to cellular organization, to the formation first of unicellular and later multicellular organisms. The primates became the final stage in the evolution of organic nature, and the starting point for the origin of man. We thus find ourselves on the top rung of the magnificent ladder, representing the progressive development of matter, this top rung being the social level. The fact that man and society are a special form of the motion of matter, the highest one, is a fundamental discovery of philosophy. Society is not just matter but spirited matter. The vehicle of the social form of motion is man as the subject of history, inasmuch as he is a reasonable social being endowed with spiritual inner life, and inasmuch as his actions are purposeful. The social form of motion is expressed in subject-object relations, that is in the relations of man, social groups, society as a whole, to the surrounding world, to objective reality. Herein lies the specificity of the social form of the motion of matter, its radical difference from all the other forms of motion. Thus there are several qualitatively different levels of the motion of matter. What does qualitative difference mean? It means that the qualitative specificity of one level cannot be explained in terms of the qualitative specificity of another. For instance, the biological organization has its own meaning, inexplicable in the framework of the physical picture of the world. In the kingdom of life, we deal with such phenomena as adaptation, metabolism, growth and multiplying, struggle for survival, mutability and heredity. There is none of this in inorganic nature. In the living organism, even the purely physical and chemical processes are directed towards the solution of definite biological tasks. Physical and chemical laws cannot explain why a monkey is ready to sacrifice her life to save her young, or why a bird can spend weeks brooding. Each level of the organization of matter is subject to its own specific laws. While stressing the need to take into account the specificity of the levels of the organization of matter, we must bear in mind certain general laws characteristic of all levels, as well as the links between and interaction of various levels. These links are manifested above all in the fact that the higher level comprises the lower as one of its genetic premises, and at the same time as its own element. The physics of elementary particles has not only conquered chemistry, it has also approached living substance in biology. Biologists have established that heredity is conditioned by the nucleus of the cell, the chromosomes, which transmit hereditary characteristics. It transpired that the answer to one of the most intimate questions of biology largely depends on chemistry, and that life is the chemistry not only of protein bodies but also of other chemical components, in the first place of nucleic acids. For this reason, physico-chemical methods must be used along with the leading biological ones, in the study of life phenomena. The study of biological phenomena in its turn enriches chemistry and physics. Thus chemistry, which studies the structures of the molecular level, has made considerable advances thanks to the appearance of quantum mechanics, which has revealed certain peculiarities in the structure of the atomic level. Chemical reactions at the molecular level being connected with intraatomic processes. The higher forms of organization, however, are not included in the lower ones. Life is a form of organization characteristic of protein bodies. There is no life in inorganic bodies. The chemical form of organization is characteristic of chemical elements and their compounds. But there is no chemical organization in such material objects as photons, electrons, and similar particles, where the irreducibility of the more complex forms of motion to the simpler ones is ignored. Relapses are frequent into mechanicism and reductionism. Thus psychoanalysis often reduces human essence to the biological components of man, neglecting his social nature. That is reductionism. To explain man's inner spiritual world, to understand the nature of his axiological and semantic links, joys and sufferings, as well as the hidden springs of volitional impulses, the power of conscience, etc., The methods of physiology, biophysics and biochemistry are inadequate. So what is reductionism? Is it always bad and scientifically untenable, or does it have some rights in science? Reductionism is defined as a methodological principle in accordance with which cognition of complex systems assumes their reduction to simpler and even quite elementary ones. The laws of the functioning of the former subsequently deduced from the principles of the functioning of the latter. However, this principle can only be applied within strictly defined limits. The method of reductionism is to some extent characteristic of all sciences, and certain achievements are possible on this path. For example, there is a tendency in modern physics towards reducing to the minimum the number of the fundamental principles of the structure of matter. At present, scientists are trying to find the common basis of the four forces of interaction known to physics: electromagnetism, gravitation, the weak and the strong nuclear interactions. Is this reductionism? It is not, because the search for the general is not a simplification of the concrete, but a step towards the truth. Explanation of the nature of, say, electromagnetism will provide additional information for the study of man, who is also a source and a receiver of electromagnetic radiations, whose strength and intensity apparently affects the human psyche. To reject the unity of the fundamental principles of the structure of matter, at all its structural levels, would mean to challenge the principle of the material unity of the world, which implies the existence of different forms of matter in motion. Motion as an essential attribute of matter, expressing the mode of its existence, necessitates also the introduction of such characteristics of forms of the existence of matter as space and time. 3. Space and time. The concepts of space and time. All motion assumes a change, interpreted in one way or another, of position in space, carried out in time, also interpreted in one way or another. Despite their apparent obviousness, the concepts of space and time belong among the most complex characteristics of matter. The science of the 20th century has filled them with content so diverse that they have often become the object of fierce philosophical controversy. So, what are the causes and the meaning of such close attention to these categories? The most general conception of space and time rests on our immediate empirical experiences. The concept of space emerges both out of the characteristics of a separate body, which always has a certain extension, and out of the different spatial positions of a great many coexisting objects. Space is now defined as a form of the existence of matter characterized by such properties as extension, structuredness, coexistence, and interaction. The concept of time also emerges both out of the comparison of different states of one and the same object, which inevitably changes its properties because of the duration of its existence, and from observation of different objects succeeding one another in the same place. Time is also a form of the existence of matter. It is characterized by such properties of alteration and development of systems as duration and sequential replacement of one state by another. The concepts of time and space are correlative. The concept of space reflects the coordination of different objects located outside one another at one and the same moment of time, while the concept of time reflects the coordination of objects replacing one another at one and the same place in space. What was the essence of the controversy about these concepts? Putting aside the various interpretations of space and time throughout mankind's cultural evolution, and concentrating on the history of natural science only, we can single out the two opposite conceptions, the substantial one and the relative one. According to the former of these conceptions, which formed in the framework of Newton's classical mechanics, absolute space and time exist independently of matter, and material events and processes proper take place in these absolutes. Absolute space and time are pure extension and pure duration in which material objects are placed. They are immutable and constant. All bodies can be removed from space, and still space will remain, and it will preserve its properties. The same applies to time. It flows identically throughout the universe, and this flow does not depend on anything, Time is a continuous world stream, a constant cosmic scale for the measurement of all concrete movements. The second conception, which arose within the framework of the dialectical tradition, was clearly formulated in dialectical materialism and later finally borne out by Einstein's theory of relativity, hence the name of the conception, and by the entire subsequent course of the development of science. The philosophical meaning of the relative approach is in the conception of space and time as forms of the existence of matter, rather than as special entities separate from matter. It follows from this conception that space and time are, first, objective attributes of matter and, second, universal in this their capacity, along with the general properties of space and time. Each of these categories has qualitatively specific properties. The specific properties of space are tridimensionality, symmetry and asymmetry, forms and sizes, location, distances between bodies, distribution of substance and field. The properties of time are unidimensionality, asymmetry, irreversibility, that is constant orientation from the past into the future, the rhythm of processes, and the velocity of change of states. The philosophical approach to space and time demands that they be considered in unity with motion and matter. The unity of matter, motion, space and time. The idea of absolute space and time corresponded to a definite physical picture of the world. The view of matter as an aggregate of atoms possessing invariable volume and inertia, mass, and instantaneously acting on each other either at a distance or through contact. Revision of the physical picture of the world changed the conception of space and time. The discovery of the electromagnetic field and refutation of the theory of instantaneous long-range interaction revealed the untenability of the classical picture of the world, and thus the untenability of the previous conception of time and space. However, all this took time. Both new facts and new ideas had to be accumulated first. A great contribution to the development of scientific notions concerning the connection between space and time, on the one hand, and matter in motion, on the other, was made by the Russian mathematician Nikolai Lobachevsky. He came to a conclusion that was highly important not only for geometry but also for philosophy. The properties of space are not always and not everywhere identical and immutable. They vary with the most general properties of matter. Lobachevsky's ideas about the unity of space and matter in motion were confirmed and concretized in modern physics. Einstein's theory of relativity revealed the direct links that tied space and time with matter in motion, and with each other. The fundamental conclusion that follows from this theory is this: space and time do not exist without matter, their metrical properties being created by the distribution and interaction of material masses, that is by gravitation. It turned out that the existence of metrical properties of space and time is a function of gravitational forces that different masses in motion exert upon each other. Without the masses, there would be no gravitation, and without gravitation, there would be no space and time. Space and time therefore do not exist without matter. Since matter is in constant motion, space and time change their properties with this motion. One of the expressions of these links of space and time with motion is the fact that the simultaneity of events is not absolute but relative. To fully comprehend this fact, it is necessary to bear in mind that a spatio-temporal description of phenomena is impossible without a frame of reference within which observation is conducted. The distance between bodies located at a finite distance from each other in space is not the same in different moving inertial systems. With the growth of velocity, the length of bodies diminishes. There is no constant length of a body in the world. It changes with the frame of reference. In a similar way, the interval between given events varies in different material systems in motion. As velocity grows, the interval diminishes. According to the general theory of relativity, the flow of time slows down in a very strong gravitational field. Imagine an astronaut flying a spaceship in the depths of the galaxy. Setting out on his voyage, he promised to send a signal to the Earth every second. Now imagine the following picture. The astronaut approaches an immensely dense star lost somewhere far in the galaxy. The density of this star is many times greater than that of the atomic nucleus. Observers on the Earth would notice, in fear and amazement, that as the astronaut approaches this body, the radio signals sent by the traveler come not every second but rarer and rarer, with intervals stretching into minutes, then hours, then years and centuries. Eventually the signals will stop coming in at all, although the astronaut keeps sending them each second, just as he promised. The point here is that neither radiations nor any particles can leave this superdense star, and it only interacts with the universe through the force of gravitation. Thus the single continuous space-time of the universe is a manifestation of the gravitational forces acting in it. The identity of the gravitational and spatio-temporal phenomena was reflected in the equivalence principle, in accordance with which the observer within a closed system cannot determine, from within that system, the character of changes taking place in it, for the external indications of the action of gravitation, on the one hand, and the accelerated motion of the system, on the other, which cause, as we know, changes in spatio-temporal characteristics, coincide. Therefore the field of gravitation and the field created by accelerated motion are physically indistinguishable, equivalent to each other. As we see, Einstein's theory of relativity confirms the dialectic materialist principle of the unity of space and time with matter in motion. The unity of space, time and motion of matter could be expressed in these terms. Studying matter in various forms of its manifestation, we inevitably study thereby space and time in their organic connection with motion, and vice versa. Studying the spatio-temporal parameters, we inevitably study thereby matter in motion. This unity was already suspected by the wise of antiquity, who visualized space as strings in varying degrees of tautness, that is, in varying degrees of tenseness, condensation, and rarefaction. This view implies the energy character of space, its organic links with matter, with its infinite activity, and the conception of space as a very fine vibrating medium full of great potential. Ancient wisdom rejected pure, empty and absolutely homogeneous space. It ascribed to space all those elements of density, curvature and plasticity which scientists attributed to it only many centuries later. Previously it was thought that these characteristics belonged to bodies themselves rather than the space they occupied. Space and time are conditioned by matter as form is conditioned by its content. Therefore each level of the motion of matter has its own spatio-temporal structure. The spatial organization of the crystal is different from the form of the extension of a blossoming rose. Living structures also have specific features of space and time. Their geometry grows complex, and the rhythms of time change, too. Here we come up against the biological characteristic of time and space. All organisms have their own biological clocks. The time of historical events also has its own structure, for the subjects of these events master time and space by organizing these events, and by experiencing them. Thus historical time is a different characteristic of time compared to physical time, say, the motion of celestial bodies. When we say that time moves faster, we mean that the events occur faster. That is, the intensity of all the forms of social life increases. Socio-historical time is measured in generations, centuries, and millennia. Its special characteristic is that historical events are stored in the memory of mankind. In this time, the reference point may be certain social events or even legends. There is also psychological time, associated with its subjective experiencing. Thus tense expectation lengthens time, while experiencing pleasure or joy tends to shorten or condense it. Time shrinks, as it were. Thus the relativity of space and time, their connection with the qualitative material content of the structure on which they essentially depend, has now stepped across the boundaries of theoretical physics, and is used practically in all areas of human knowledge. On the multidimensionality of space, the theory of relativity employs the concept of a unified spatio-temporal continuum or as it is sometimes called, of four-dimensional space, in which time is added to the three familiar spatial parameters. This is done in order to fix a given material object more accurately than is possible in ordinary three-dimensional space. Einstein himself said that he was surprised at the caution with which four-dimensional space was sometimes treated, although this concept means no more than the fact that a body with given spatial coordinates occupies a given position at a given point in time, the fourth dimension. David Hilbert's multidimensional space is quite a different matter. Now, what is that multidimensional space? What physical and philosophical meaning does this concept have? Its purpose is to reflect the presence in the object under study of certain entirely non-spatial properties, which are merely expressed as space-like in terms of various mathematical operations. Thus, if three coordinates expressing, say, the three components of an object's impulse are added to its three familiar spatial coordinates, the sum of all these data is said to be a six-dimensional phase space. Although there are only three properly spatial coordinates here, as UCL, the concept of six-dimensional phase space is a mathematical abstraction, and it does not at all claim to have supplanted the concept of three-dimensional space. Multidimensional space is not a fiction, but neither is it space in the direct meaning of this word. The use of the method of multidimensional space is accepted in quantum physics, which has to describe the phenomena of the microcosm inaccessible to sense perception and therefore to visualization, expressing concrete physical phenomena of the microcosm with the aid of concepts worked out in the classical physics of the macrocosm. Multidimensional spaces are a justifiable scientific abstraction which has both physical and mathematical meaning. There is nothing supernatural or meaningless here. Various idealist interpretations of multidimensional space, such as the theological constructions placing all kinds of spirits, or the ideal substance itself in these fifth, sixth, etc., dimensions, are not proposed by physicists or mathematicians themselves, who clearly understand the nature of the abstractions they introduce, but by idealists who exploit the achievements of natural science, or by those who do not fully understand the meaning of this new category, the dialectics of the finite and the infinite. It would be hard to find a person whose imagination was not struck, at some time or other, by the mystery of the abyss of the universe, by the sight of the dark sky with myriads of sparkling stars in it. In our everyday life, in all that surrounds us, we deal with finite objects and phenomena. Finite means moving towards an end, limited in space and time. Infinity is interpreted in the sense of anything sufficiently large or sufficiently small, which depends on the conditions of a given task. Thus, 1,000,000 raised to the 100th power is a practically infinite magnitude. Our experience does not permit us to answer definitely what infinity is. The ancient Greek philosopher Archit thus visualized infinity: take a spear and throw it as far as you can, go to the place where the spear has fallen, throw it still farther. We may repeat the procedure as many times as we like, and we will never come up against a boundary beyond which we could not throw the spear. Therefore space is infinite. It is also simple and clear. Hegel called this kind of infinity bad. However far I may place the star, I can go beyond it. The world is nowhere boarded up. One Hegel pointed out that it would be wrong to interpret infinity in the sense of unlimited repetition of one and the same act. This is a merely quantitative, and therefore limited, understanding of it, illustrated for instance by the natural number series, containing the possibility of unlimited addition of more and more units. True infinity, opposed to the bad one, is a process of continual movement beyond the limits of the finite, a movement that is not just quantitative but qualitative and even essential. One measure of the definiteness of a system passes into a qualitatively different one, both great and small. Any system, however great, is finite in space and time, but in the transition from one link in the chain of the world hierarchy to another, one system of properties and relations passes into another possessing its own measure, that is, qualitative and quantitative definiteness. In this sense, infinity is qualitative diversity of hierarchically organized systems of the universe. Then, true infinity is also a process in the sense that the universe is a reality continuously creating itself rather than something accomplished and given once and for all. The finite is a constantly emerging and disappearing moment of the infinite process of change in that which is. Change is in general connected with the passing of a system beyond its spatial, temporal, quantitative and qualitative boundaries, the endless web of the connections between objects and phenomena in the world, of their energy and information interactions, is continual movement beyond the bounds of the finite and the particular. True infinity is a process of constant qualitative formation of the new comprising the infinity of space and time. It is a 1 GWF Hegel, System de Philosophie, Part 2, Die Naturphilosophie, in GWF Hegel, Sämtliche Werke, in 20 volumes, Volume 9, Fromans Verlag, Stuttgart, 1929, page 72. Dialectically unfolding process of acquiring boundaries and losing them, of achieving equilibrium and at the same time tending to disturb it, that is to say, it is a constantly intensely pulsing process of the unity of opposites. The infinity of the time of the existence of the world is expressed in the concept of eternity. Eternity is a property of the world as a whole, of which each concrete system is transient. Acceptance of the eternity of the material world is a cardinal principle of the dialectical materialist worldview. In religious and idealist philosophy, the concept of eternity is connected with the idea of God, or of the absolute spirit. God is conceived as an infinite and absolutely perfect being abiding in eternity, not in time. Quantitatively, eternity is manifested in the actual infinity of the intervals of the being of systems and events, succeeding one another centuries and millennia. Qualitatively, it denotes an infinite series of changes in the material forms of that which is. Epistemologically, infinity is conceived of as a process, in principle impossible to be completed, of expansion and deepening of the subject's knowledge of objective reality. We know incomparably more now compared with the past generations, but there is a bottomless pit of the unknown ahead, and the future generations will have to handle it. The concept of the infinite and unlimited in natural science, a philosophical conception of the essence of the finite and the infinite, the limited and the unlimited, presupposes generalization of the achievements of science. This is mostly associated with the modern interpretation of gravitation. We know already that the general theory of relativity, which demonstrated the connection between spacetime and matter, generally describes space as non-Euclidean, curved. Einstein regarded the gravitational fields of various bodies as space curvatures in the areas surrounding these bodies. But does the entire world space have curvature? World curvature is defined by the curvature of all the world lines passing by massive bodies. If, for instance, we take the totality of the world lines of all the bodies of nature, these lines curve more strongly near gravitation centers. Planets cause weaker curvatures than stars. Gravitation is weaker in intergalactic space, where world lines straighten. Since all world lines are subject to curvature, space in general may be said to be curved. Naturally, the infinity of space thus perceived does not coincide with its unlimitedness. Indeed, let us imagine an insect, like the blind beetle which Einstein described to his son, crawling on a ball, moving on the surface of the sphere over an unlimited period of time. It will never encounter any boundaries. The sphere is unlimited in 2 dimensions. There are various interpretations of the curvature of world space. Some are inclined to interpret it as proof of its closedness, and in this sense finiteness similar to the finiteness of any spherical surface. Movement in this space in a strictly determined direction will not necessarily be movement away from the starting point, but owing to the inner curvature of space, it may end in a return to the starting point from the opposite side. This problem is similar to the one discussed before Magellan's circumnavigation of the globe. Is it possible to sail in some strictly determined direction, say west, and to reach eventually the starting point, coming to it from the east and having covered a finite distance. The unlimitedness of space does not mean its infinity. Others assert that the finiteness of space does not at all follow from its curvature. The clossedness of space is merely a particular and idealized, because it assumes uniform distribution of matter in the universe, case of its curvature. Although curved, space remains infinite, whatever the solution of this issue in the natural sciences. The concept of infinity in dialectical materialism has above all a qualitative rather than quantitative meaning, the more so that the concepts of space and time are relative. This problem is especially acute in various cosmological theories. As we know already, modern cosmology generally accepts the theory of the origin of the universe out of the Big Bang. There are three varieties of this theory. In one of them, the gravitational attraction between the slowly receding galaxies is so strong that at some moment, it will make them begin to draw together, even to the point of reverse condensation or collapse. According to another theory, the galaxies recede so fast that the gravitational forces will never be able to stop them, and the universe will go on expanding infinitely. According to the third theory, gravitation is close to the critical magnitude, which hinders both the infinite unfolding of the universe in space and its reverse condensation, thus avoiding the collapse. How is the issue of the finiteness or infinity of space resolved in these theories? The first insists that space is finite but has no limits, while in the other two space is infinite. In all of them, however, the problem of time is unsolved. Time turns on the moment of the Big Bang, and in the first of the theories, on the moment of the big collapse. Does the fact of the explosion signify the beginning of time, and the fact of the collapse, its end? The answer assumed by scientists but not yet confirmed by science is this. Space and time end at the moments of explosion and collapse, but they only end in the sense that we now know. Before the explosion and after the presumed collapse there are other space and time, so far unknown to science. This answer essentially coincides with the one provided by dialectical materialism, which accepts the inexhaustibility of matter, and of the forms of its existence. Still, what can this new state of space-time mean? Why do scientists assume the existence of heretofore unknown forms? Attempts are made to answer this question by creating a quantum theory of gravitation. In the past, the founders of quantum physics faced similar problems in connection with the stability of the atom. Discharging energy, the electrons would inevitably have to fall on the atom's nucleus, that is an analog of the big collapse. But none of this happens, and quantum physics thus explained this fact. If the electron fell on the nucleus, it would have to have quite definite position and velocity at that moment, which is impossible in terms of the indeterminacy principle discovered by quantum physics. Physicists place their hopes of constructing a quantum theory of gravitation on the possibility that at the Big Bang and big collapse points the properties of space, time as we know it change in such a way that the continuous flow of space and time disintegrates into quanta. In other words, just as the field concept, space and time acquire quantum features, which brings them still closer to the general properties of matter, and further confirms the correctness of the principle of the material unity of the world. It will no longer be possible to say that the bang and collapse points are the limits of time and space. It will have to be definitely said that the spatio-temporal forms of the existence of matter acquire a qualitatively different character here. Our well-established and largely empirical notions of space and time will have to be repeatedly revised in the future, but one point will remain immutable: space and time are objective. They are universal forms of the existence of matter, qualitatively infinite just as matter itself. So far we have considered the problem of infinity in relation to the cosmic scale of the existence of matter. We have dealt with the so-called extensive infinity. The just as infinite world of the tiniest particles of matter represents the so-called intensive infinity. Human thought ranges from areas measured in millions of light-years to areas of the order of 1/1000th of a centimeter. In this latter area, Space and time apparently have special properties, although it is not excluded that they are similar to those we know. Thus all objects and processes in the world are finite, but the totality of these finite things and processes is infinite. There are no borders beyond which there could be something that would not be covered by the concept of objective reality. It is in everything, and it is everything. The concept of limit has meaning only in relation to the finite. In conclusion, it should be stressed that the task of philosophy is not to offer a final solution to the problem of infinity, relying on the entire body of concrete scientific knowledge, on the history of knowledge and culture as a whole. Philosophy establishes the worldview and methodological significance of the theoretical thought search for a solution of one of the deepest mysteries of being. Chapter 4: Consciousness, Essence and Origin. 1. The general concept of consciousness. Definition of consciousness. Man possesses the wonderful gift of reason, with its keen insight into the remote past and future, into the world of dream and fantasy, a gift that affords creative solution of practical and theoretical problems, and realization of the most daring plans. Since the earliest antiquity, philosophers have striven to find the solution to the riddle of consciousness. Heated debate on this subject has raged for centuries. Theologians see consciousness as a tiny sparkle of the grandiose fire of divine reason. Idealists insist on the primacy